Yeah, thank you very much for coming. Nine, awesome for hosting. Google, thank you for the beer. Really, cheers, everybody. Thank you for showing up, even despite the warnings and all of that. And not shaking hands. So I'm all good. Should I wait for a bit? OK. So I'm a Kubernetes engineer at Swisscom, dealing with on-premise clusters. So it's part of my day job. But during the night, I tend to, other than sleep and party as a normal ex-student, I tend to build really cool shit on Kubernetes. So I figured out that chaos engineering and Kubernetes is an interesting idea, but I have a different presentation style right now. I'm testing it out if it works. We'll see. It all started with this thing. So I saw Google actually offered a way to run your Kubernetes. Oh yeah. If you have questions or you see that something is you're not really certain about something that I've spoken about, you can raise your hand. I'll try to address it. But if you think that is going to take a lot of time to explain, such as what is Kubernetes, up at the networking would be great. So preemptable instances on Google. I saw that this was a feature available. In a previous life, I worked in a startup where we had mostly of our infrastructure on Google Cloud, also on other clouds. But this was the last thing that I saw before I left. It was that I could run Kubernetes nodes using preemptable nodes. And that was really interesting. Because preemptable VMs are basically things that die really fast in a very unforeseeable fashion. And if you want to do that, you cannot really run a standard workload on Kubernetes. You would have to, let's imagine that you're running Postgres on Kubernetes. Imagine, because I do that on a daily basis. So you can't really expect to have a SIG kill on your master node and not be able to do a failover. You would be screwed. Your data, you might have, you have to run FS check on your volume. So don't do that. This is interesting because if you if you architect your platform somehow, you might be able to run on this. And it does give you a considerable saving. I think it's about half price than normal ones. So, cool. Let's try to run this. We have a very weird ephemeral cluster. Random nodes may die. But maybe we can run something cool. So if you remember from the old days, 5 years ago, Kubernetes was really built for stateless applications. And it works really well on that. If you would switch to stateful, it works. That's amazing. It's really cool. But you're losing some of the features, such as if suddenly one of your nodes dies, you're screwed. Yes, there are ways around it, I know. But in general terms, if you don't prepare for a random VM shutdown, have fun. So I wanted to build an application that can survive such a chaotic, let's say, environment. And I went on Google and I searched. And they do have this recommendation of how to build cloud-native applications. Design for automation. OK, makes sense. Be smart with state. I don't like when people use the word smart for something, but OK, fine. Favor managed services. Yeah, that's duh. And practice defense and dev, that really got me confused. We'll see about that. And always be architecting. OK, makes sense. Things change. New services appear on Google Cloud or on AWS. Depends. Maybe you should migrate. You'll see. But that's pretty good. It gives you a very good idea of how you should build an application. Am I too loud for the people outside? So let's start with designing something for automation. The basic thing. If a node dies, another one should spin up, right? If we have a lot of traffic, we should get more nodes. In theory. This is not for traffic, because we're just actually increasing the number of available nodes for our cluster. So in this case, we are allowing us to scale to 0 if there is no traffic in our cluster. Not traffic. I think by default, the autoscaler for the VMs works on CPU, if I'm not wrong. OK, cool. So that's basically check. Cool, awesome. Smart with state. So I really wanted to build something cool on Kubernetes that can die. Problem is, I wanted to run WordPress. So I'll explain why afterwards, but I ended up realizing that I can't do that. I'll explain later. I'll actually explain in a second. So we end up running some kind of application, but the trick is, because we're smart with state, we can run as a deployment and not as a stateful set. Really freaking important. Because if you run as a deployment, you can scale so well. And of course, I'm using Google's load balancer because I'm on GCP. Well, I'm not going to run something else. And favor managed services, of course. Sure, I'm not going to run my own Postgres. I have Google to run it for me. And that's what I did. But I wanted to run WordPress. And I saw that if I want to run NFS on GCP, so basically the Google file store and then plug it into my Kubernetes, it's $840 a month, which is fine for your regular workloads, but I am using my free credits for this. So you can understand my reservations. What can you do in this case if you don't have shared storage? You build a really tiny Docker container. 27 megabytes might not seem that tiny. This includes assets, like real assets. I'll explain how it's built later on, but so when I'm booting a new container, it's there. Yeah, defense in depth. I read this chapter. I mean, it makes some sense. It's like trying to make your application secure by design. We're going to skip this for now because it's a demo. Always be architecting. I'm sorry for the inverted colors. I didn't know whether it was going to be a screen or a projector, but basically added Kubernetes should work now. Increased replicate count, not as many. My GitHub commit history does speak for itself. I'm always architecting when I'm pushing. So if you have a phone, you can actually go reach this. This is not part of a demo. It actually works now, so you can check it out. It's a very standard blog. And that's how it looks, only of course these colors are inverted because I do like black more than white, so. Hey, sorry, wrong phrasing. Please do not quote me on that. So, but the main idea about this concept is like, okay, you've explained to us what running stateless applications on Kubernetes is cool. We all know how to do this. What's the point of chaos engineering? I want to be able to predict what will happen when something happens. So I have like an idea that if a VM would die, my service or application survives, but I'm not sure how. And that really, it does make sense. You'd want to make sure that your production system is fault tolerant without having faults in it. But how do you do that? So how do you like organize something like this to happen without being Mother Nature? And there's this really cool thing. It's called, this is the only slide with actual text. So if you actually want to remember something or take a screenshot, this is on principlesofchaos.org. You can get this if you search for the GitHub of Chaos Monkey, which is the Netflix tool for doing chaos engineering. It's really that. Like, you're trying to understand that your system is capable to be resilient by creating random things in production. And really, at the core of chaos engineering, there is this is from Gremlin. It's a really cool company that basically, I think some of them used to work for AWS or for Netflix, and they spun out and they built this. And yeah, I do like the concept of planning a hypothesis because you know what's like going, like what event are you going to trigger. Then you make sure that this event that you're triggering will at one point have some impact on your system, but you're trying to contain that because if, let's say I suddenly kill all my VMs and my cluster is dead, cool experiment, you've just killed production. That's why a lot of people are scared of running chaos engineering in production. They all prefer to staging or to test. That's not the point. Running chaos engineering is making sure that you build resilient applications. And building resilient applications means that you should be able to run a Chaos Monkey in production and not to be impacted. Of course, we're not at the scale of Netflix. Swisscom is pretty large, but doing such a thing, you really need to be able to do really good experiments. And that's important. If you would think that chaos engineering is just going to production and killing random containers, fine. That's a certain point, but it has a bit more to it. And yeah, scale or squash, basically there is a process for this. I do not actually go into the entire chaos engineering process. If you want to read about it, there is so much online, really. But for this, I wanted to explain the reasons why one would try chaos engineering in their cluster. And yep, I usually include this in all my talks. Please don't. I've built there's like 5 or 4 projects in this demo. This one I think is the coolest one. I finished it on Sunday. It's really amazing. So this is a web server running on Google App Engine, and it's very cool because it listens to a certain post request. I'm not going to explain now. And what it does is then it goes to Google Cloud API and triggers a VM shutdown. Not even a shutdown, a destroy. Now, managing cloud resources. You can do GUI, cool. You can do CLI, cool. YAML templates for every single cloud provider are available. Terraform is better. What I ended up doing is curl, using Go, because it's awesome and it's surgical. Like, I know exactly what I want to target. I know exactly when I want to target it, because everything else would take way too long for this demo to work. And it's a very simple architecture, actually. My phone talks to the disruptor server, which goes to my chaotic cluster. The whole point is that I don't want to re-architect this application and submit it to Apple Actually, I do have an APK, so on Android as well. And I tried to use Flutter. I'm really sorry. It was way more difficult, and I preferred using React.js for this because my brain works in Go and Node. That's how it works. So, and it took me about 2 to 4 weeks to actually build the app. I'm sorry about that. It's like I really suck at front end. And then it goes to this disruptor server, which is amazing because it takes a post request sent by the application. So now I can modify the server as easy as I can and still keep compatibility. And then it has basically service account login and on App Engine because it's really easy to do so. And it goes and directly kills one of my instances in my instance group for GKE. So if you're using GKE, when you create it, you get an instance group. Usually, you're not supposed to delete VMs, usually, but you can. So, allow me to demonstrate, because this is, honestly, I had so much fun building this. This is not a simulation, this is actually my phone. So, cool. So, let's see. If you want, you can access the website. It's on demo.mat.md. It works for now. Let's just do a refresh just to double check. OK, I still have internet. Amazing. We go to posts. We have some really cool ASCII. And will the demo work? This doesn't look like much, but these weird numbers is actually a custom load generator that I just wrote. So we have that. Amazing. Let's go and see what our VMs are doing. And watch this, please. Watch. OK, so I forgot to mention. GKE is set to autoscale. Also, I have a horizontal pod autoscaler. If you don't know what it is, basically you select the metric of your container, in this pod container. And in this case, it's CPU. Actually, I could probably describe it really. Nah, I won't do it here. Basically, it will increase the number of pods that you have for your deployment based on a certain metric. In my case, it's CPU. So when it reaches 50% CPU utilization, it will spin another pod. And that's the benchmark. And this is a second benchmark just for get. So we're just going to start our get benchmark.
A question.
Yes.
Then, what's the general architecture of the whole setup? You have several pods running WordPress, and you have one database service, or what do you have here?
Thank you for asking. OK, so quickly, the actual, I think it's like this. If I go, I had to build something that is not on WordPress because, as I said, I had that bug using some sort of shared state, so shared assets. That's why I ended up using a Go binary to compress all the assets into like a very small Docker container. This is a fork of a very simple blog with Buffalo, but I would prefer to spend 8 hours upgrading an application to Go modules and fixing dependencies, because this is a 2-year-old project, than to write my own blog in Go. And this basically has just a Postgres connection to Google Cloud SQL. It's not running in HA mode because I don't need it. All of these servers are actually pretty low latency because we're all running on the Google Cloud region in Zürich. And yeah, it's a very simple application that can be scaled, actually, I think, indefinitely. since I don't have state. So it's really cool for that. And this talks to Postgres and Cloud SQL, and itself, the cluster runs on GKE on the same region, and then you have the App Engine there. It's a very simple architecture, not much. And what I wanted to basically show here is that if we start this get benchmark, just to make sure we have some consistent load on the cluster, of course, why not? I'm going to, the Q actually is the QPS. So I am rate limiting myself, but now we're going to do it 50 because why not? It's a demo, things should break. So we're starting this. So it's basically warming up our pods. Up here, 21, I don't know if I'm going to zoom in. It zooms in everything. That's a bad thing. So this is trying to keep some sort of a number of pods that we're currently running. So as you can see, just a simple GET request does not trigger much for Go. At least, did it run? It is running. And we're going to simulate some sort of a user posting comments. Let's say, yes, it's Go, so it's easier to do environment variables. OK, that is working right now. That is still there, and these are the VMs. So if I would go now here and I would refresh, please, unless it broke, which might definitely happen since this is a demo. Nope, we're not receiving any comments. So I guess this is not working, my benchmark. Go build, let's go. We're gonna, oh, I know what happened. My cookie changed. Okay, so wait a sec. No, it's all good. All good. Let's see our time. So clock. Okay, we have time. Don't worry. Back here. So the nice thing about working in cybersecurity before switching to ops is that you do know how some systems work really well. So we're going to intercept the cookie now. And our interceptor is off. Perfect. This is Firefox. Interesting. I would have to expect this to break, so that's fine. Unless I manage to accidentally break the entire thing, and I would be very impressed by this. Because it shouldn't break just randomly. Let's try Chrome. No, Chrome is fine, so I guess my proxy is not working great. Okay, that happens. Never mind, alternatives exist. So, for now we still have our lovely blog, and we still have my phone. And we still have some sort of a bench running here, and we have our VMs. The entire thing is, why would you run this? I want to make sure that if I have a VM die, my application will survive. So, you can obviously do this, and it's going to work. Because if we go back here, stopping 1, and if we continue, yes, there is some weird glitch in my Go loop because I'm querying what is the latest VM that is running and not stopping. So if I do it too fast, it will report that the one that is stopping is actually running. So let's go kill some VMs. 1, 2, 3, and yes. OK, fine. The benchmark is still running, so it's not reporting any weird issues, although the actual benchmark might be broken, so who knows. We're going to try to fix this thing, and I hope that we can run some sort of a, maybe magic, who knows. We go back to posts. OK, cool. So it's starting to break. VM-wise, we're only 4 VMs down. And we're starting to stage, oh, also, we're running containerd and not Docker because it's faster to provision VMs like that. And I don't, there might be a way I'm actually rate limiting myself. Does anybody, can somebody access demo.mad.md? Just to make sure it's not me who is getting into the issues.
Yeah, it works.
I think it's because I'm running all of this on the same. OK, so let's just kill everything. Control-Z will not help me here. Please, die. OK, you can go to post, and it should still work. OK, of course, it's a live demo. I've been told that things should break. So, OK, cool. This finally finished. This should be dead. OK, we're going to stop all curls. OK, fine. I think I just lost internet connectivity, though. Never mind. Since you guys can still access it, and we were still running this weird, like, combination of things, let's just, we'll detect. Do we want to do this? I don't know.
You can use the public Wi-Fi.
Do we have access to it?
Yeah, the guest.9.ch. The password is open source.
How do you spell it? Wait.
It's just a word.
Hey, thank you. Awesome. Okay, you're gonna save my demo then. We're gonna go here. We're gonna do this, and then I'm gonna get banned from the 9 Wi-Fi. Okay, 20. This is working. That is back. So, do we still have? Yes. Awesome. Hey. Okay. We're starting to post random comments everywhere. Perfect. So my Go loop has a 2-second timeout. Else, I think Google will ban me. So we can continue doing this in a very easy way, and we start killing more things. And our VM should start dying. All of them, please do die faster. I really tried using curl for this because it's much faster than any other way. Come on. Part of this demo, I actually thought I could give my phone to somebody, and then I realized, like, if this auto scales, I'm screwed. Okay. And we go back to post. It still works amazing. Doesn't matter. Yes, we're still having a connection to our database, and we're getting load balanced across all of the different pods that we have available. Perfect. Yes, it's not the most exciting demo, but it does work. Thank you for the Wi-Fi thing. That really helped, and I should stop my benchmark, because else, who knows what could happen. So, quickly back to the presentation. Yeah. So, this is part of Kubernetes a Fun Way series that I have. That's why, like, even though I work for Swisscom, I'm still wearing my GCP socks today. So, this was episode 1 where I tried to run a cluster under my TV. Really awesome, works pretty well. Like, there is a write-up of that one. There's a write-up running drones on Kubernetes. And this is the third one, which there will be a write-up available as well. And I'll try to link with the slides together with this video. If you want to actually work and understand the core principles of chaos engineering, I would recommend reading through the stuff that Gremlin has. It's easy to digest. It has a nice UI if you want to schedule your attacks. I didn't use it for this specific demo because I noticed that their poll rate to their servers is about 15 seconds. And then scheduling a node shutdown is about a minute. It wasn't really, like, it's not a good representation of how preemptable nodes work. And also I had to run a daemon set, which pulls a very huge image compared to mine. This is the original. This is what you should check. This is what you should know. Chaos Monkey from Netflix is, I think, like one of the core reasons why a lot of people know about chaos engineering. It's amazing. And if KubeCon or Cloud Native Rejects is not canceled by tomorrow or something, I will actually do the 4th episode of this thing there. So feel free to join us on Sunday before the conference. And Q&A. Thank you. Really? No questions. I'm surprised. I couldn't follow myself. Well, thank you, and enjoy the beer.